Hola, mi clase. All right, we are putting together lessons 7 through 9. This is where we've been learning about using rigid transformations to determine whether two figures on a grid are congruent. So we only have 2 vocab words today. That's nice. So lift that flap up, get these written down so we have them in a finite place. So rigid transformation or transformations is a move that does not change any measurements of a figure. Those are translations, rotations, and reflections. Or any sequence of these are rigid transformations. So I can do translation, reflection. It's still a rigid transformation. Congruent is one figure is congruent to another if it can be moved with a translation, rotation, and reflection to fit exactly over the other. So if we can do rigid transformation, then it is congruent. So the first 2 problems we're going to do is just review to talk about area and perimeter. Those always get a little confusing. So area is the inside, right? This is the inside. And perimeter is outside, like a fence. Okay, so area of a rectangle is just these inside squares. So 1, 2, 3, 4, 5, 6, 7, 8. We would say 8 units, and we technically say they are squared because it's the inside. And then perimeter, just for visual sakes, I'll change the color. Perimeter is the outside, like I'm building a fence. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And perimeter is just like a measurement, so it's not squared. It's just units. So that's just a quick reminder of the difference between area and perimeter. All right, let's get into talking about the things we've been doing. This is also a little bit of review of what we did in sections 4 through 6. So it says determine the coordinates of an image point to -5 after each transformation. So remember, we wrote those generalized coordinates for x-axis reflection and y-axis reflection. So remember, x-axis was x, comma, opposite y. And then y-axis was opposite x, keep the y the same. So if we applied that to this point, my a prime would become, leave the x alone and take the opposite of 5, so it becomes -5. And if I applied this, a prime would then be -2 and leave my 5 alone. Oops, I forgot my negative. So put that negative on there. All right, so we're going to determine if this figure is congruent. Remember, if it's congruent, it means a rigid transformation has happened. All measurements will be the same. Area, perimeter, lengths, angles, everything about it will perfectly copy and be the same. So if I just look at it, I can reflect it, and it would end up looking very similar, right? If I take A, B, C, D and reflect it, it'll look very similar to E, H, F, and G. However, if we look at AB, 1, 2, 3, 4, it's 4 units across. AB is the longest side, and the longest side of EFGH is EF. And if I look at that, it's 1, 2, 3. And that's only 3 units. So since a measurement changed, this is not congruent. A measurement changed. Okay, remember, congruent means everything will match. Like, yeah, I could reflect it, yeah, I could translate it, but then it would not copy on top of it. And if you remember with our definition, that's what it said it would do. It would land perfectly on top of it. Okay. Some test practice. So just practicing how our test questions will look. So this one asked us which of the following cannot. So we need to be careful with these. If you need to highlight them or whatnot, you can see it's a little italicized, but when we read the directions, we really need to make sure we check these things. So it says which one cannot be the result of a series of reflection, rotation, and or translations of segment AB. So here's AB, it's 1, 2, 3, 4 units. That means if it is a rigid transformation, it will be congruent. What I'm looking for is not congruent. So if I look at line CD, it's 1, 2, 3, 4. That's congruent, so that's not a choice. If I look at KJ, I have 1, 2, 3. That is not congruent, so yes, a choice. NP is 1, 2, 3, 4. That's congruent. Not gonna, that's what they don't want me to look at right now. LM 1, 2, 3, 4, 5, 6, 7, 8. All right, that cannot be the result because it's not congruent. And then line GH 1, 2, 3, 4. That's congruent. And then line EF is 1, 2. Not congruent, so it cannot be a result. So that's how I would break down that problem. Check each one and figure out which ones cannot be equal, right? Congruent means equal. All right, let's go to questions 2 and 3. So a pentagon ABCD was graphed on a coordinate plane and then rotated 90 degrees counterclockwise around the origin to form pentagon A prime, B prime, C prime, D prime, E prime. Which statement is true? So the first thing I want to mention is this is our rigid transformation. So all things congruent. So everything has to be congruent. So it says pentagon A prime, B prime, C prime, D prime, E prime is not congruent to pentagon A, B, C, D, E. Well, I just wrote, if it's a rigid transformation, it is congruent. So that would be false. That's not true. It is congruent. The area of pentagon A prime, B prime, C prime, D prime, E prime is not equal to the area of the pentagon A, B, C, D, E. But I just said that everything has to be congruent. So it says not equal. Congruent means equal. So it's that one's false. The angle measures of pentagon A prime, B prime, C prime, D prime, E prime are congruent to the corresponding angle measures of pentagon A, B, C, D, E. Well, that is true because if it's congruent, it means it all is equal. And then the last one, the perimeter of pentagon A prime, B prime, C prime, D prime, E prime is greater than the perimeter of pentagon A, B, C, D, E. That would not be true because that's not congruent. Alrighty, triangle ABC and triangle XYZ are congruent. Okay, so that means everything matches. They're gonna land on top of each other. Which sequence of transformations will move triangle ABC onto triangle XYZ? So what I would do is just pick a point and start moving them around and see what happens, right? So if I do a reflection over the y-axis, that means these will all flip over here. So this is C prime. B prime would be here. And then I need to translate 2 up. Well, look at that. Those definitely land perfectly, even if I checked A prime, which would be here, and went up 2. So that's done. Just to go over it, just to explain it, if I did an x-axis reflection, it would end up down here. And then to move 2 more is nowhere near that. So that's why that one doesn't work. Erase what I just did. There we go. If I did the next one, I would end up where C prime and B prime are, but now it wants me to move to the right. Well, that's going the wrong direction. So that's why that one won't work. Okay, I'm gonna erase that little arrow. And then the last one says reflect over the x-axis and move to the left. So again, x-axis ends up here, left ends up here. It's nowhere near where we need to be, so we will get rid of that one. This is how I would work through these test questions. That's why I'm modeling them the way I am modeling, okay? It's not just for funsies. All right, and then we're done. That was a quick one. So until next time, adios.